Hey everyone, and welcome to my very first introductory course on machine learning and data science, linear regression in Python. This course is the perfect course to start with if you are interested in deep learning or machine learning and you have no idea where to start. In this course, we start with concepts that I think almost everybody knows about. If you took high school math or physics, you already know what a line of best fit is, and you know how to take a derivative from high school calculus. You also know about matrices and vectors from high school algebra. This course is very hands-on, so we're not only going to discuss concepts, but you're also going to implement all of these concepts in code. Python is a pretty easy language to learn, so long as you have some concept of for loops, if statements, and other basic programming techniques. You should be able to follow along. It would help if you've used NumPy and Matplotlib before, but it's not critical. The code examples are very short, and it should be very obvious what's happening. Now this course is very practical and hands-on, so I don't count watching me type as following along. I expect you to write code yourself. This course doesn't have grades, so you need to have some way of knowing if you understand the material or not. How you'll know is this. If you can derive all of the equations I derive in this course by yourself without looking at the videos, and write all of the code in this course by yourself without looking at the videos, then you've passed this course. So what content will be covered in this course? First, in the next lecture, I'm going to give you an outline of what machine learning is and how linear regression does it. Next, I'm going to introduce you to one of our course examples. We're going to use linear regression to show that Moore's law is true. Moore's law states that the number of transistors on a chip doubles every 2 years. This will show you that linear regression is very applicable to the real world, as Moore's law is one of the most famous results in computer science. After I introduce you to this problem, I'm going to give you all the tools you need to solve this problem. The basic idea is we want to find a line of best fit. We'll do it in a somewhat abstract form, looking at the problem in a geometric way. It is very important that you're able to visualize what's going on. Some people think machine learning is just plugging numbers into an API, and they couldn't be more wrong. All of the problems are geometrical, and you absolutely have to be able to see and visualize the problem and the solution. In the section after, we'll extend the problem by adding more input variables. With Moore's law, we only have one input variable, which is time. It's actually fascinating that time is all we need to predict the progress of technology. Compare that to working with images, where we can have thousands or millions of input variables. Luckily, we won't be going from 1 to 1 million right away. I will show you how we can go from one input variable to 2 input variables. Once you know this, it will be very easy to extend to any number of input variables. At the end of this course, we'll discuss some advanced machine learning concepts, and I'll give you a general overview of possible directions you could go after taking this course. I primarily want to set you up to learn more about deep learning, which is currently the most popular machine learning technique, and in terms of artificial intelligence is actually modeled after the brain. I designed this course to give you the basic tools you need to get to the next level. See you in the next lecture.